Great. So you've just finished reading about how to create standalone messages. So now let's go over some takeaway messages and ideas that you should be getting from this little lecture. One is this simulation uses a single module, and the output of the module we want to monitor because we want to see what happens when we connect it different ways. And so we added a recorder. You've already seen how to do that. The new element is really this standalone message. Now, why would we do that? Well, we don't always have to connect to another module's output message. Sometimes it's very handy or even required to connect to a standalone message. Here's an example. In flight software, some algorithms need to know what the spacecraft inertia is. Because we want to make sure the inertia is the same in all the modules that need the inertia information, we specify that in a message. And it tends to be a standalone message, just like shown in this figure. That way, if some control module or estimation module needs to know what's the inertia of the spacecraft, it can just read it from this common single message. So that's an example. Another one is unit tests. When you're writing modules, we want to have just the module work. So if some number comes in, we multiply times 2, then what comes out should be twice what goes in. And you don't want to connect that to a bunch of other modules because that'll create extra dependencies. I just want to make sure there's one module's working. So there too, we make the module in Python, and then we artificially just create our own standalone input messages. Here's the spacecraft position, here's the attitude. Both of those get ingested by the module, and then we check the output. That's kind of what we do with unit tests. So there's a variety of reasons why we want to have standalone messages. So let's quickly review how this works. The message is really a message object which has content, and the content is what we call the payload here. So to create it, you have to import messaging again, and then you can see you would have some message type. So this could be your attitude guidance message payload, and this gives you a copy of the C structure that defines the content. That's the structure that might have the position and velocity and attitude message in it or other states, right? And message data will simply be a copy of that structure. So once we have this container for that, for those variables, we can start populating it. Just like you do with structures in C, you can just, or any other structure in Python, you can then do that object dot the variable name, like position, equal to something, and then you can populate it. Now that the message content has been created, we have to actually create a message object and put that content into that object. So that's why it's a two-step thing. This line here, back to the messaging system, it does everything for you. You would then have messaging dot the message type, ending just in message, not payload. Message payload gives you the structure. If you end with message, it gives you the message object. So for attitude guidance, this would be dot at guide message as an example, as we'll see below. So now we have a message object. So how do we get this message data into the message object? Well, there's a method for that. And you have basically message object dot write, and then you give it as an argument the content. And that's it. Now you've written to the message. You notice here there's no time. There is actually, as I think it's discussed all below, you can add time if you want to when you write messages, but here I'm not giving time. So by default, this should be 0. So instead of doing 2 steps, you can do this in 1 because this is such a common operation. So the first one is the message from the messaging system, create this message object, the attitude guidance object, great. And then in line, you can do dot write and give it the content that is supposed to put into that object. So if you want to, you can simplify. Let's look at the code. This code sets up a single module. Within the module, we add it to a task and get going. Now we want to create a standalone message. So from the messaging system, we're going to do one of this dummy message type, flight software template message payload. That'll create the structure. It has a single vector inside, a 3D array. So we're going to specify that to be equal to 1, 2, and 3. I know, very imaginative. And now in one line, we create the message object, that's the standalone message object, and write the message data into it like we saw above. Now, when we connect the module's input message to this standalone message, you notice we just do data, data in message.subscribe like before, but then we just give it the message object. So this illustrates the message object doesn't have to always reside in a module. This is just, it can also be a standalone one. Then we're setting up a recorder and we will pull it and we execute it for 10 seconds. So they will start to do some stuff. You can go look at that module to see what math. It's really not important, it just does stuff. But then after it finishes executing, I'm going to illustrate here, I'm actually changing the message, the standalone message data from 1, 2, 3 to -1, -2, -3. Here, I'm just changing the payload copy. This, you still have to write this step because this takes that and actually puts this content into the message object itself. So this would run 10 seconds, then you're going to change that input message, and then I'm going to run another 10 seconds. So that's what I'm designating here. So I've increased my absolute simulation time from 10 to 20. So it's going to run up to 20, it's another 10. Execute, then pull. And so around 10, we should see this discrete change in some of those logged variables. So let's go take a look. I'm going to go back here. This is the right script. And if I'm going to run this for 20 seconds, you can see this module keeps proudly saying it ran. That's cool. But the plotted one, you can see here, everything's good. These two states, 1 and 2, basically stay constant in this module, and all of a sudden they're copies of the input. Then after 10 seconds, they become minus what they were originally. Whereas the 0th one pulls in from the message and it keeps adding 1. That's why it keeps increasing. And then it pulls in that other number, but still keeps increasing. So that's why these changes that you can see as expected. So this is a demonstration how you can, whoa, I didn't mean to do that. This is a demonstration of how you can write a standalone message, even change it. And if you wanted to, you can, here when I'm writing, the time the message was written here is 0, because this module doesn't care when the input message was written. But if you wanted to, you could have done here also message data and then said comma, 10 converted into nanoseconds, of course. And then you would have that designation too. So all the little subtle variations, things to remember. But anyway, have fun writing standalone messages.